has any causal effect on the trends that we see on the economic side. And what I think, if I'm figuring out the terminology from other disciplines this morning, I'm going to first talk about the economic theory of it, which relates to the mode of action, if I'm getting my terminology right. So why would we expect there to be a causal effect, at least theoretically? And then we can talk about how we actually go about testing that in practice to see whether or not we can find evidence that there really is a causal effect going from regulation on various economic outcomes. All right, so that's where I'm going. Trends. So on the environmental side, like I said, I'm focusing on the manufacturing sector. That's what a lot of economics research, where it focuses its attention. It may not necessarily be the largest polluter or the most relevant polluter for ozone, but it is subject to a lot of the debate, and it's where we can also find evidence to look at these things. So this first picture is just showing what's on the y-axis is pollution abatement costs incurred by manufacturing, divided by the value added provided by manufacturing. So what we see overall is it's roughly 1% over this time period going from 1974 to 1994. There's actually 3 lines on the graph, and if you want to, the bottom one that's the squares, I guess I actually have a laser pointer, is reflecting that what's going on in practice for manufacturing over time. What's interesting, though, if we care to look at the top 2 lines, is what's going on is it's holding constant what would have happened or what would have been regulatory cost had the distribution of manufacturing stayed the same as it was at the beginning in 1974. And the fact that these other 2 lines lie above what we actually observed in the given years means that there was a transition within manufacturing from relatively dirty sectors within manufacturing to relatively cleaner sectors over time. All right. And that's going to kind of be a running theme through what I talk about is a lot of the heterogeneity within manufacturing, building on the heterogeneity from this morning, and how that affects the way economists think about regulatory costs. Quick slide just on comparing abatement costs to in the U.S. to some other developed countries. So this is just a graph of the fraction of capital expenditures within manufacturing that are devoted to pollution abatement from 2000. And so the U.S. is roughly in the middle of this picture. At the bottom, the 2.8% of all capital expenditures are claimed to be devoted to pollution abatement. And that puts us roughly in the middle and certainly below some other countries that are in here like Australia and Canada. Shouldn't have been a blank slide in my slides. Okay. So on the emissions side, just one picture. We can move on. Ozone's gone down a little bit over time. In terms of, these don't look very good. It's 33%, isn't it? It's 33%? What? No,
That's concentration, it's not emissions. Right. I think it's 33%. That's a pretty good decline.
Okay.
That's what it says.
Yeah, it's taken from, if I could get that bottom part off, it's taken from the EPA website. So yeah, I guess if you want to look at it in more detail, I was going to, interest of time, skip over it. But so it says national trend based on 222 monitoring sites. So you're seeing the distribution within a given year, the national average relative to the standard. And so the bottom would be the cleanest site among the 222, and then the top. And so clearly there's been a decline at the most polluted sites. All right, but I'm a little worried on why my pictures are not clear. Maybe it's just this one. All right, so then trends in terms of manufacturing, even though the picture's a little garbled. What the picture's showing is just over the last 30 years or so, manufacturing output has gone up in terms of real terms, in terms of just the level of output. That's the blue line that's supposed to be on the top. And then in terms of productivity, that's the other line that you can't really see. And the point is that productivity, and here it's a very crude measure of productivity. Economists spend a long time measuring, give a lot of thought to measuring productivity. This is a very crude measure of just output per person, per employee, and that's been going up, way up over time. What I don't have a slide on is just showing employment or employment share in manufacturing, and both of those have gone way down over time. So the number of employees in manufacturing, both in level terms as well as a fraction of the labor force, have both been going way down but productivity's been going way up, and then as a result, output's been going way up, even though there are fewer workers in the sector. All right. And this is just a breakdown kind of by time period, showing the growth rates in productivity over time. All right. I'm not missing half the slide. So anyway, instead of a data on manufacturing trade, I had a quote, but it's half here, just showing that over the last 30 years, that the U.S. has incurred a trade deficit in manufacturing. Most recent numbers are about $440 billion in 2012, I think is what it said on the bottom half of that quote that's cut off. And that makes up the vast majority of the U.S. trade deficit is from manufacturing. So that's another piece of the puzzle with more manufacturing occurring overseas. All right. So anyway, that's really quick highlight of some of the trends over the last 30 years that relates to this stuff. So we know that manufacturing employment's declined in both levels, as well as the percentage of the labor force. We know that output's still risen in manufacturing, and that manufacturing sector is more productive in terms of being measured in terms of output per worker. We also know that the U.S. has become a net importer in manufactured goods. And then on the environmental side, emissions have gone down. That shouldn't say area pollutants, but air pollutants. But emissions have gone down, and that abatement costs have also increased as a percentage of value added. So now we want to know, kind of beyond the trends, whether or not these things are related, and that's the issue of causation that we've been talking so much about. As we know, correlation does not imply causation. This is just another picture illustrating that if you just want to look at time trends, we see manufacturing output going way up, and then pollutants, the criteria pollutants going way down over the last 20 years or so. But just because there's a correlation doesn't mean that there's anything necessarily causal going on. All right, and that's what we want to figure out. All right. So like I said, before going into jumping into the studies that actually look at the data to try and tell whether or not there's anything causal going on, like I said, it's helpful to have a theoretical understanding to think about modes of action in an economic sense on why there might be a causal effect of regulations on the economy. So economists have a very simple way of incorporating environmental regulation into our typical models of firm behavior. Conceptually, we can just think of pollution as a typical input, no different from labor or other capital or things of that nature that go into the production process. We use up the environment to produce some goods that are pollution intensive, and regulation just acts as a way of increasing the cost of one particular input. And once we conceptualize it like that, then things that economists have been doing for hundreds of years become very straightforward to think about how firms might respond to an increase in regulatory costs. All right. Whoa. So in terms of thinking about the theory, on the productivity and employment side, again, this is only half the slide, but there's one of the ways that regulation may affect productivity is by affecting the composition of the firms that are actually in the market. And so what we mean here, and what's been stressed in the literature, in particular in this Greenstone et al. Paper, is that regulatory costs may drive the least productive firms out of business, and so you're truncating the lower tail of the productivity distribution. And so that has important implications, because if we just look at like those figures on what's gone on with productivity over the last 30 years, it looks like productivity has been going up, and it has been conditional on the firms that are actually continue to produce in the market. And so that may be misleading, because we may be missing the fact that there's been deaths of these firms that have dropped out of the market. All right. The other part that doesn't show up on here that relates to productivity is another issue that's been referred to as the Porter hypothesis. And instead of a productivity effect coming about through this composition effect, there's an argument that there's a productivity effect through innovation that's spurred by environmental regulation. And that's become well known as this Porter hypothesis. Goes back to this guy Porter, who was believe in the business school at Harvard at least in the early 90s. I don't know if he's still there, but wrote in the early 90s on this. And so the argument, there's different variants of the argument, but essentially the idea is that when you have more stringent regulation, firms try to research to figure out how to comply with these things, and then, they may stumble upon better ways of doing things, or they may just update their capital in order to pollute less, and then as a result you get these other productivity gains that are just kind of accidental byproduct of environmental regulation. I'm not saying believe it or not, I'm just saying that's at least a theoretical argument that's been put out there on how regulation may impact productivity. All right. Then on the location side, there's a fairly lengthy literature that looks at firm location in general in economics, and then Henderson in the mid-90s extended this to thinking about regulation in particular and how that impacts firm location. And he has a very simple theoretical model, nothing very scientific about it, but a supply and demand of entrepreneurs who may want to enter a market. We get an equilibrium where you have so many people enter the market and you have firms earning so much profits. But then when you raise regulatory costs, it's going to reduce the amount of profits that entrepreneurs can earn, and so fewer of them are going to want to enter the market. So we get this nice straightforward prediction that if we raise the costs through regulation, then we should have fewer firms locating in a given area, and those that do produce there should earn lower profits. All right. And then the last little bit on the theory side we can talk about are some theories that have international implications rather than just within a country. And so we have this well-researched idea over the last 20 years that's known as the pollution haven hypothesis. And so it's a similar story to the one before on firm location, but now instead of firms moving from an in-attainment or an out-of-attainment county to an in-attainment county or something like that, we can have firms relocating abroad. And then those countries that specialize, if there are some, but countries that may specialize in having very lax regulation and then want, in an effort to try and attract a lot of pollution-intensive firms, then we give them the names that those would be pollution havens, and hence the name for this idea. Whether or not that happens in practice is obviously an empirical question, because lots of things change once we start moving across countries. And so whether or not firms would actually want to do that, whether or not environmental costs are important enough to motivate them to move to a different country for production is an empirical question. And then similarly, comparative advantage stories of international trade, just as countries specify in goods that use intensively the inputs that they have a comparative advantage in. And so again, countries may derive a comparative advantage by having very low environmental regulation, very lax regulation, and hence then may specialize in pollution-intensive goods. And then if they do, then they should become exporters of those pollution-intensive goods, and then other countries that have more stringent regulation should export relatively clean goods. All right. So that's kind of the theory side. So then we move from the theory to the empirics. So we want to test these different theories and see if they, whether or not the data bear out that there is a causal effect of regulation on these different outcomes like productivity or export behavior, import behavior, or where firms choose to locate, all this sort of stuff. So as we've been talking about all morning with the EPI studies, once we start to do this, we have lots of empirical challenges that make it difficult to answer. So here I'll just talk briefly about two of those, some of which are redundant, well, both of which are semi-redundant from this morning, that we have to rely on observational data like the EPI studies and how we measure regulation, measurement error issues. So observational data, this will be my 2 cents worth on all the correlation causation stuff from this morning. So whenever we want to go test this stuff, we don't have the option of running a randomized control trial. We can't set up a map and throw darts at it. In counties that get hit, they're labeled as non-attainment, and those that don't get labeled as in attainment, and then we get to see what's going on. So we're stuck with looking at real-world data that's observational, and so issues about confounding and all these other sorts of things that came up this morning, these are very real things, and economists, these are what economists who do this kind of work, this is what we spend all day thinking about, is ways to use observational data to try and make convincing arguments, at least, that there's causal relationships or there's not a causal relationship in the data. All right. I think it's useful to take a step back from this morning and just speak very briefly about how we think about causation within economics, and it's really borrowed from the lengthy statistical literature. And there's this well-known, now it's referred to as this counterfactual approach to causation, or this potential outcomes approach that goes to Heckman, who won the Nobel Prize in economics a few years ago, and Rubin in statistics, and goes way back to other statisticians back in the 30s, are all kind of cited in this general literature. And so the counterfactual approach is very simplistic, but it's also a very powerful way to think about not just the studies here, but also obviously the epi studies from this morning. What we mean when we talk about a causal effect of anything, any sort of treatment or policy or intervention, is the difference for a given observation, a given person, or a given place between what actually occurred with the treatment and what would have occurred had the treatment not occurred. All right? So you have a realized state of the world, and then you have the alternative state of the world that was not realized, but what would have occurred had everything else stayed the same, but only the treatment was changed. All right? And that's typically what we think of as causation. All right? And that very simple statement makes a very obvious point, which is that it is impossible to estimate causal effects with observational data without making some assumptions, because a causal effect means the difference between what actually occurred and what would have occurred in that same space and time, space-time continuum or whatever, had the treatment not occurred. And obviously you can't observe two states of the world in the exact same place at the exact same time. So anything we do to try and estimate a causal effect has to start making assumptions in order to estimate that missing counterfactual. And so randomized control trials, I guess the case control stuff, that was the terminology that was being used this morning. That's a quote unquote relatively easy way to circumvent this problem, assuming the randomization and everything is done appropriately. There still can be issues and blah, blah, blah. But randomized control trials are a fairly standard way to do that, to circumvent this problem. But obviously, as I said, we can't do that in this literature. We can't randomize environmental regulation to see how the economy changes. All right. So the point is that when we can't do randomized control trials, any study has to make some assumptions. All right. And what's underneath the black part says that many of those assumptions are inherently untestable. So all this stuff about uncertainty that people are talking about this morning, it's exactly right. There's always going to be uncertainty. But it also kind of begs a larger question that, that high quality studies, what's high quality to one person could be low quality to somebody else. Every study has to make an assumption. And some people may believe those assumptions and some people may not, and there's only so much you can do. And so I think in economics, the way we write papers is not necessarily that you write a paper and we necessarily believe that that's the right answer, but transparency is what's key. Here I have a set of data set. Here are the set of assumptions that I make. If you believe these set of assumptions, here's the answer that I get. And then we can all draw our own conclusion on whether or not we believe those assumptions or don't believe those assumptions. And I think what that gets to is kind of when we aggregate the literature, which we do in economics, just like was being talked about this morning in the epi studies, it's not necessarily that we want to do 20 studies that all follow the same methodology to see if whether or not all 20 of them get the same answer, although there might be some validity to that. But you also want a host of papers that use different identification assumptions to see which different assumptions give us different answers, and then we can kind of boil it down to seeing which of those assumptions do we believe the most or not. All right. The other thing that comes out of this, I think that wasn't really touched on too much this morning, is that what immediately comes out of this counterfactual approach is that for any given observation, for Dallas County in 2014, if they're labeled in attainment, they would have a certain level of economic activity. And Dallas County in 2014, if they're labeled out of attainment, they would have a certain level of economic activity. And the causal effect of attainment status on Dallas County is the difference between those two, one realized and one hypothetical outcome. But that treatment effect for Dallas County may be different from what Houston County would get or any other, I don't know, my Texas geography, I'm not a native Texan. But for any other observations. And I think so. Some of what I noticed, I think that was lost in the discussion this morning is at least in economics, we don't talk about a single treatment effect or a single causal effect. We really think unless you start making additional assumptions, every observation has a different causal effect, in theory at least. And that means that different studies can estimate different parameters, and you're not necessarily comparing apples to oranges. And just as a kind of more of a rant on this sort of stuff, we talk about In economics, the difference between what we call ceteris paribus effects and versus policy effects. Ceteris paribus being Latin for all else being held constant. And so randomized control trials, they estimate ceteris paribus effects. You hold everything else fixed, you just flip the treatment in your little steel cage with your rats or whatever, and then you estimate some effect, and everything else is being held constant. In the real world, you might have these sort of, compensating behaviors. If we say it's a high ozone day, then people stay indoors, and all these other sort of things. And so it's important to think about these different things answer different questions, and what's relevant for policymakers may be different than what scientists care about and all this sort of thing. But it's important to realize, to think precisely about what it is actually that's being estimated in any given study and whether or not it's comparable across studies. All right, that's kind of my rant. All right, so the other challenge relates to the measurement error stuff, concept with exposure that was talked about a lot this morning. We have measurement error. If we're going to try and measure the effects of regulation, we're going to need a measure of regulation. The problem here is a little bit, I think, even more difficult than the exposure stuff this morning, in that at least with the exposure, you can conceive of how you can get rid of the measurement error problem. We could attach, I'm not a scientist, but a little respiratory reader thing on people and follow them around, and you could actually have the readings that individuals are exposed to. So at least in theory, there's a solution. As you can see from the quote, and that's discussed in the literature, it's hard to even conceptualize what a good measure of environmental regulation should be when we're going to go to look at whether or not it has causal effects on various economic outcomes. And so that's an issue that we have to deal with. That's not good. All right, so what's my overview? And then I'll talk, I don't know how much time I have left, but I'll talk briefly about some of the studies in this area. So the economics literature in this area has evolved over time. The early studies ignored a lot of the econometric difficulties associated with causation and measurement error and these sorts of things, and they tended to find no relationship between regulatory stringency and adverse economic outcomes. More recent studies attempt to overcome these hurdles through better data on outcomes, panel data, better data on environmental regulation using attainment status, using enforcement data, or using some sort of complex indices based on pollution abatement control expenditures. And then using more sophisticated econometric techniques, and particularly moving beyond even cross-section to panel data and then to what we call instrumental variables. And I don't know if that means anything to anybody, but ways to try and consistently estimate causal effects in the face of potential measurement error or unobserved confounders. So I'll run through some studies in this area just to give you a flavor, and you can tell me to stop talking anytime if I'm going too long. So some early studies in this kind of relatively new literature, and I guess in the interest of full disclosure, Henderson was one of my professors in grad school. Not that he wasn't my advisor, but he was at Brown when I was there. So anyway, he had a series of papers in the mid-90s that kind of, I think, jump-started this literature. So he had data at the county level from 78 to 87. The measure of regulation was whether or not counties were in attainment for the ozone standard. And then the outcome that he was interested in was the number of establishments or plants in 5 three-digit industries based on total VOC emissions. And so I think the one thing that you'll notice, and probably the one punchline that comes out of all these studies is, if you want to tune me out for the next 5 minutes or so, the big picture is that most of these studies tend to find significant effects, but you have to look really hard to find them. Meaning you have to look for specific industries where these environmental regulation costs really are a large chunk of their costs. And so it's not all manufacturing. If you look at manufacturing as a whole and whether or not regulation has causal effects on various economic outcomes, you're not going to find anything. There doesn't tend to be anything there on average. You get these heterogeneous effects, but here we have a story for the heterogeneity, which is it's these select few small industries where they're big emitters of these particular pollutants, and then you can find an effect of regulation on their behavior. So these papers by Henderson look at the number of plants in a county in 5 three-digit industries, where he chooses these 5 industries because they account for the vast majority of VOC emissions. And he finds that if a county's in attainment for the prior 3 years, then you're more likely to get a new plant in a given year by 5 to 10%. And being in non-attainment reduces the probability that you get at least one new plant. Then in follow-up work, Becker and Henderson, and Becker was Henderson's grad student. He was a fellow grad student of mine. They did some work in now where they got restricted plant level data from the census. And again, they focus on a particular subset of industries. And these subset of industries account for only 6% of all manufacturing. So again, you're looking kind of for that needle in the haystack where these effects actually are likely to exist, and then they're finding them. And again, they're focused on ozone attainment status. So what they find is that, again, counties that are in non-attainment have about a 26 to 45% lower probability of getting a new plant in one of these particular sectors. Again, looking at data from 63 to 92. Yeah, I also do this stuff on plant size and find this interesting result that if a firm is going to build a new plant in a county that's out of attainment, they build a much larger plant than firms that are building a new plant in attainment counties. And then over time, they kind of converge. But if you're going to build in a non-attainment county, then they're building big. So Greenstone, very similar. Again, all these have the similar spirit to them. The one difference here is he focuses on more than just ozone attainment. He has attainment status for 4 different pollutants, and then focuses on a little bit bigger subset of the manufacturing sector, but that are sectors that are high pollutants in one of these 4 categories. And he finds that over a 15-year period, so combined over all 15 years, non-attainment status across all 4 pollutants, so not just ozone, cost 600,000 jobs over the 15-year period. It's not annual, it's aggregated over the 15 years. And again, aggregated $37 billion less in investment and capital in these counties, and $75 billion less in output. But to put that $75 billion, for example, in context, total manufacturing output in 1985 alone was about $1 trillion. So you're talking about $75 billion aggregated over 15 years relative to an output of $1 trillion in just 1 year in 1985. Some papers by List et al., and again, in the interest of disclosure, I'm in the et al. Part of these papers. So we had data just from New York State, county level data, and again, we just focused on ozone attainment status, and we had a series of papers looking at new plants, relocating plants, foreign plants versus domestically owned plants and stuff like that. And we did find that, again, non-attainment reduces the number of new plants or relocating plants that a county gets. But interestingly enough, foreign-owned plants were much less affected, or much less sensitive to whether or not a county was in attainment or not. Just another one. Similar stuff. Ozone attainment status, again, focusing on particular industries, and again, finding effects, but again, for only those sectors that are severely affected by the ozone regulation. So those are all firm location studies. So then briefly, there are a few studies that look at productivity. So the one that I mentioned here was kind of really the first big, as far as I know, economic study that looked at this Porter hypothesis idea, this idea that regulatory stringency may increase innovation as firms research to how to comply more cheaply with the regulation. So what they did is they had industry level panel data and looked at whether or not industries that spent more on PACE, on pollution abatement, whether or not they invested more in R&D in the first place, and then whether or not that R&D translated into a measure of innovation, which they argue is arguably noisy, but the best they could do, and whether or not that translated into new patents that firms were deriving. And they found that it did increase R&D, but it didn't lead to any new innovations as far as they could tell in terms of increase in the number of patents that firms were applying for. And then there's a more recent paper, again, by Greenstone and some co-authors, focusing now on productivity rather than the prior measures that he looked at. And again, he's got data on attainment status across 4 pollutants. And so the big punchline in this paper, which, again, in full disclosure, this paper is a little bit old now and has not been published. It's still a working paper, and I'm not sure why people haven't liked it to publish it, but I'll throw that out there. But the punchline of their paper is that regulation reduces productivity by 2.6%, but that's an underestimate because it ignores the fact that the least productive firms were driven out of business. And so then once they do some fancy econometrics to control for who's driven out of business, they actually find that productivity is reduced by 4.8%. So it's biased down by about half because of this non-random selection of low productivity firms exiting the market. All right. And I think it's the last two papers that I'll talk about. So then there's two recent papers by this guy Walker that are different from the earlier literature because his first one focuses on very detailed firm level data, and his second one actually focuses on following individuals to see at an individual level what the outcomes are. So this first paper's got manufacturing utility plants from 95 to 05. And he's got a specific measure of regulation at the plant level rather than at the county level. So he interacts whether or not a firm is in a non-attainment county, and then they're also in this EPA's permit database, indicating that they're subject, that plant in particular is subject to regulation. And he looks at plant level employment. So he finds that non-attainment status reduces employment over the next 8 years, and it's gradually going down over the next 8 years if a county switches from being in attainment to all of a sudden being out of attainment. And that eventually after the 8 years that employment stabilizes at 15% below where it was when the county was still in attainment. And like I said, the last paper is very similar in terms of the measure, but now what he's got, instead of following firms, he's actually following workers. He's got this database that's very cool, where you observe workers over time. Even if they lose their job or change jobs, then the data still follow these same workers. So what he finds is that if you're a worker who is initially working at a plant that becomes regulated all of a sudden because that plant now, the county switches from being in attainment to now being out of attainment, then not surprisingly you lose some of your earnings, 16% of your earnings before the regulation, before you became out of attainment over the next 9 years. And then if he extrapolates and does some multiplication, he attributes the total cost to $5.4 billion in lost earnings over this 9-year period after a county would switch from being in attainment to out of attainment. And that's particularly, not stated here, but if you follow it up, it's particularly concentrated among unskilled workers, low education workers, and older workers who have a difficulty finding a new job if they lose their job. And also most of the earnings comes from jobs being destroyed, not from individuals who retain their job but now in the regulated plant. So there you don't see much of an effect. It's really from individuals who lose their job and then because they're unskilled or older have more difficulty finding a new job afterwards. All right. I guess there's way more. I'll summarize. So then there's a series of papers that do similar stuff, but now looking at international impacts. And so the literature at the international level has similar measures of environmental regulation. And again, we're breaking it down to particular industries, but now the outcome, as opposed to firm location or firm productivity, we're going to look at net imports in the U.S. So the basic question is, as environmental regulation becomes more stringent in certain sectors, are we more likely to import those goods from overseas and no longer produce them here? And again, most of these studies, this one by Etherington and then Levinson and Taylor, one by Hannah and then one by me, all find again that, yeah, there is some effect. This is true, but it's really small and it's really concentrated to the industries that are extremely pollution intensive in the pollutants that become more highly regulated. All right. So my conclusion, past 4 decades have witnessed kind of a tremendous amount of change, both on the environmental side and the manufacturing side. Theoretically, these things may be related to each other. However, econometrically, it's hard to prove, but we think we've done some good work. Not just we as in me, but economists have done some good work, even though, yes, they all have to rely on some assumptions, but the authors in these papers try to justify those assumptions, and they seem credible. So the best evidence to date suggests that regulatory costs do adversely impact these outcomes, but only for a select few industries that are heavy emitters of the pollutants being regulated, and that are also what we call footloose, that are more mobile industries. So lower shipping costs, or easier to close down a plant here and open up a plant in Mexico or something like that. And if we want to see what are those industries that we're talking about, just pulled from one of those papers. So when I say that these various studies tend to focus on a select few industries, these are the industries you can see in that first column for ozone. These are the industries that are typically focused on as being the heavy polluters of ozone, where we see the effects. And then I'll stop.